All right. So good morning, everyone. It's great to see you all here. My name is Catherine Shee. I'm a product manager for the AWS Data Pipeline service, which those of you coming from Werner's keynote may have just heard about. And I'm going to give you a quick overview of, first of all, what this thing is, and then we're going to do a little tour of how you'd actually use it. So what is Data Pipeline? This is a lightweight workflow orchestration service for data-driven workflows. And the idea here is that if you're trying to build some data-driven workflow, there's all this nitty-gritty detail you have to worry about. What happens if your data doesn't arrive on time? What happens if one of your processing steps fails? What happens if a transient error takes out one of your machines? And you don't really want to have to worry about this stuff. You want to focus on the business logic that's going to make you more successful and that's going to actually create value for your organization. So Data Pipeline makes it so you can ignore the stupid details, focus on the business logic, and everything else will just work. Like all AWS services, this is on-demand pricing, pay only for what you use. There's no minimum commitment, no upfront fees, and there's going to be a free tier. So if you want to do things like basic replication of Dynamo data to S3, there'll be no charge at all for that. And more on pricing later. So I'm going to do 3 things here. First, discuss the general problem and go into how Data Pipeline would help you address this. And finally, I'll give you some examples of creating pipelines either through the console or through the command line interface, and then show you a little bit about how managing pipelines would work. So let's talk about the problem. To make this a little more concrete, say you've got a website with premium content, and your goal is to improve your business by better targeting this content. So you could just show every user everything, but you could do a lot better if you start showing specific users things that you think they're likely to want to see or purchase. So your goal is to improve your targeting, improve your business. You've got a secondary goal probably, which is that right now your application works. It's generating logs in some format, storing its data in existing databases. You could start mucking around in there trying to rewrite the data to be more friendly to your analytics, but it's going to be a lot safer for you if instead you make your analytics friendly to your existing data. And then finally, like all else, you would love to do this better, faster, cheaper. So let's talk about your existing data. There's a variety of data sources it could probably be in, and it's not just going to be in one of them, right? If I told you to take S3 and use this for all of your data needs going forward forever in time, hopefully you would boo me off the stage, because it's a horrible idea. Instead, we should be thinking about, for each piece of data, is what are your specific needs around this data store, and then you should be picking a data store that meets them. So for example, if you're generating lots of event-type data, you have real-time IOPS needs, you want to be sure you're going to hit that, you should be saying something like DynamoDB, where you can provision a level of throughput, and you're guaranteed to get it. On the other hand, if you've got a lot of bulk objects you're trying to store somewhere, maybe S3 is a great fit for that. And so different parts of your application are going to be using different data stores depending on what's best for them. So going back to our hypothetical, what data does our current website probably have? Well, in all likelihood, we have some historical web server logs, so we know who's been clicking where. We probably know how long it took to generate their content. We can maybe reconstruct clickstream logs from this. For registered users, we probably got some real-time information about what they've purchased, what actual transactions they've done. Again, for registered users, we probably have demographic data from when they signed up. So we know how long they've been on the platform. Maybe we know where they live. Maybe we now know how old they are, things like that. And then let's say we've purchased data to a third-party IP geolocation service. So if we have a visitor's IP address, maybe we can tell that they live, for example, in Las Vegas. And where is this stuff going to be? Well, our web server logs, taking a whole bunch of big chunks of data, sticking those in S3 would make a ton of sense. For our user demographics, this is classic relational data, right? So maybe it's on-premise database, maybe it's RDS. And then for our event data, about who's been subscribing to what, who's been generating what events, this is Dynamo. And then from this, we want to generate some kind of smart analytics, intelligent output, just say some usage statistics, analysis. For those of you who were here yesterday, this is going to be Redshift or some kind of data warehouse, right? So we want to take all this different data, load it into Redshift. But it's not that simple. You don't want to just take these logs and blindly shove them into a relational database because they have no structure. It's just not going to work. What you actually need to do is take all this stuff, perform some analysis, add structure to your unstructured data, and then think about loading it into your relational data warehouse. So we've already added a step of complexity. And as time goes on, this is only going to get more complex. It would be awesome if all of our bosses said, you know what, targeting's pretty good, we don't need it, turn off the systems, go home early, have a beer. I have yet to see that happen. Instead, what happens is someone comes up and says, hey, your targeting's great, but wouldn't it be better if we started adding Twitter data? Or if we added, I don't know, information about the weather. Maybe people, when it's sunny, want to see the beach. Maybe people will say, hey, we're curious not just about the events that happened, but about what dollar the transaction level actually was. Maybe you start running simulations. So you run analysis of, hypothetically, if we extended this A/B test in this direction, what results do we think we'd see? Maybe your users have created videos or images that you want to analyze. Maybe you have sensor data. So if you have a mobile phone application, maybe you know what the GPS coordinates of your users were. And maybe you've purchased additional third-party data sets. I could stand here all day and add extra things to this list, but I think the point is clear. You're only going to have more and more different data sources and different data formats feeding into this analysis. And as you have more and more of these, it's going to become more painful to try to manage them. What happens if one of them goes down and the others are unaffected? What happens if there's a fluke in one of your external APIs? So this is where Data Pipeline comes in. So we're going to first talk about what the basic functionality is, and then we'll go over how you'd actually use it in this example. So at a very high level, Data Pipeline consists of Datanodes. These are the things that hold your data. So a data node could be a directory in an S3 bucket. It could be a DynamoDB table. It could be a table in a relational database, either on AWS or on-premise, anything like that. And then activities are things that act on your data. So an activity could be a SQL query. It could be a script running on an instance, some 20 lines of Perl. It could be a big EMR job that's going to chug through petabytes of logs and produce some complicated analysis. And typically, your activities are going to generate even more data. If you have a SQL query, it's going to have some output, which you probably don't want to just drop on the floor. If you have an EMR job, again, you've paid some money for that output. You'd probably love to keep it. Occasionally, you'll have an activity that's maybe send an email. So output data nodes are technically optional, but we generally recommend that you have them. Adding a bit of complexity, you can attach preconditions to your data nodes, and activities get failure and delay notifications. So let's talk about those a little bit. So preconditions, there's two classes. There's ones that rerun for you. So for these, you don't need to have any kind of long-standing compute resource. And then there's ones that you run. So for ones that rerun, we can check for existence of S3 files or directories. We can check for existence of data in Dynamo. And then we can run queries against RDS or Redshift. So for example, you could say, this data is available once this RDS query returns at least 100 rows. Or my data is available once I see my last hour of web server logs in S3. Then there's some data sources that we can't check easily. So for example, if you have an on-premise JDBC database, we cannot reach through your firewall magically and query that thing. So we give you the ability to run queries against it. I'll have some more details later about how this works with on-premise resources. And then also, we give you the ability to express preconditions as custom scripts. So if you're, for example, querying a third-party FTP, it's not something that we host, but we give you the ability to write the code to do that and easily plug it into the system. For retries and notifications on activities, by default, we retry all activities 3 times. So this gives you some resilience against transient failures. If something has a brief fluke, it's no big deal. Processing will continue. And you can configure this. So if you're running some really heavy job that takes lots of compute resources for a long time, maybe you want to go with a very low number of retries so that you detect failures early and you don't pay a bunch of money to repeatedly try something that you don't think is going to work. On the other hand, maybe you're running a quick little SQL query against a database that you know is kind of overloaded. Maybe this thing tends to time out. then you can just crank up your retries and not really worry about it. And then we provide this concept of lateness. So lateness lets you say, hey, I think this activity is going to take 5 minutes to complete. If it starts taking 2 hours, something is really, really wrong here. You've got 2 options for lateness. One is to notify yourself and then keep on trying. The other is to say, that's it. It gets 2 hours and then it's done. I want you to stop it. So we support both of those. And then for notifications, you can also notify yourself via SNS when an activity succeeds, if it's late, or if it outright fails. So if you've exhausted your attempts and you have to go intervene, fix some things, and then actually click retry, which would reset that. So you can then, all right. So architecturally, how does this work? This big green blob at the top is us. So Data Pipeline sits on top of your existing resources and provides management and orchestration. So it's going to signal your compute resources when it's time to do stuff. It's going to monitor your data to decide when it's time to do things. It's not that the data actually flows through it, but instead that it's on top providing management and resilience. And you can take this individual step of data to compute to data, and you can chain it together in interesting and complicated ways. So here's an example pipeline, a little bit abstract. When we begin execution of this pipeline, the system's going to look for the data in the top left. So nothing's running until that data is there. Once the data is there, the activities that consume it begin to execute. And these things go independently. So the one on the top right could succeed before the one on the left. It's done, its data is ready. The activity that consumes that data, though, is still waiting for the output from the other one. So it's going to keep on waiting. Eventually, the data appears, and the activity starts to run. Now, in general, we recommend that you have explicit data nodes in between your activities. This gives you better statefulness and makes retries a little bit easier, but it's not strictly required. Maybe you have activities that for one reason or another can't actually put their data into a cleanly modeled data store, so that's fine. In that case, we let you directly chain the activities. So here we've chained 2 activities. Once one completes, the other just starts to go. And then as it finishes, you see the success move through the pipeline. And then all of this stuff runs on a schedule. So at a very basic level, a schedule consists of a start time, an interval, which is how often the stuff should run, and then optionally an end time. So we can make this a little bit more concrete. An example schedule would start today at noon. It would run every hour, and we're just going to say this thing runs forever. So when you take this schedule, what happens? Well, today, the first interval is noon to 1. So that time, we kick off a copy of the pipeline. We start looking for the first data node. When it's there, we do its activities, continue on. The same thing happens from 1 to 2, 2 to 3, and so on. And once we have this, we can configure what Matt was talking about in the keynote. Oh, sorry. If during this, let's say the 12 to 1 data never becomes available, that's totally fine. It's not going to interfere with processing for your subsequent set of logs. The 12 to 1 block will hold up waiting for that data. The other periods will continue to execute just fine. So now we can go on to what Matt was talking about, which is this idea of rollups. So let's say we have this hourly processing, and we want to produce a daily summary of everything that was in our logs and all the activity we saw today. We can define another schedule with a daily interval, and we can create an activity that consumes all of these individual hourly buckets. The system will just know that usually there's 24 hours in a day. Twice a year on these annoying days, there's either 23 or 25. It handles all that stuff. And as always, if one of the input data nodes never becomes available, that's fine. The activity will just pause and wait for it. And again, if you had lateness notification configured, you'd hear if, for example, this data node 2 days later still wasn't there, you'd start to get the SNS messages saying, hey, maybe you should go take a look at this. And you can chain together your rollups in interesting and complicated ways. I'm not sure who would actually want this many steps, but it's totally possible if that's you. So let's go back to our example problem. because we've got this website with the premium content. We want to improve our targeting. So to break this down a little bit, say we form a plan. We're going to do 3 or 4 steps, depending on how you count. So we had that geo lookup data that we'd bought. We have our server logs to tell who's clicking on what. And we're going to try to merge these so that we can say users from this geography like to look at this, users from the other geography maybe behave in some completely separate fashion. Then we have our event data. And we're going to try to merge that with what we know about users from when they signed up to again say maybe different types of users are doing different things. We're going to load all of this into a database so that we can programmatically consume it on web servers and do dynamic targeting. And then we want to take the results, put them in a reporting dashboard, and generate some automated reports for a business owner. So let's look at step 1 first, merging the geo lookup data with the server logs. Here, pipeline for this part is pretty simple. We have S3 logs. We've got a third-party API with our lookup data. Let's say we're going to use an EMR streaming job because our logs are probably pretty big. And then we're going to load the results into Redshift. We can add some preconditions. So for S3, we'd use a file exists to make sure that the logs are actually there and that none of the servers have been delayed in sending the stuff. For the geolocation data, we could use a custom script here because who knows what the third-party API exactly looks like. Once these preconditions are met, we'll start doing the processing, and then the results will go into Redshift. Step 2, merging the event data with the demographics. This is pretty simple, too. It's another pipeline. We're combining 2 data sources, in this case, Dynamo and RDS. And then results into database. That's already done by those 2 pipelines. So all that we have left is step 4, displaying our results in the dashboard. Again, here, even though it's a single database, you'd actually model this as 2 data nodes in Data Pipeline because they're probably separate tables. And Data Pipeline is modeling things kind of at the logical unit, not at the physical unit. So we're going to model this as 2 tables. When they're ready, we run some reporting query. Out comes an email. So plan is done. And to build the pipeline, you can just take each of these individual things you've constructed, stick them all together, and now you have more complex behavior arising out of these relatively simple logical building blocks. And then we translate this to our data nodes and our activities. So let's talk a little bit more about what the activities can actually be. We support 4 broad classes. The first is arbitrary Linux applications. So the system knows how to call out to the Linux shell, run anything that works there. We also support copies between different data sources. So for example, if you have CSV data in S3 and JDBC data, we give you the logic kind of out of the box to just move between the 2 of them. You can run SQL queries and then EMR jobs. And we can run these on 2 classes of compute resources. So we have ones that we manage and ones that you manage. Talk about the difference and cover the ones that we manage first. So what does it mean for a data pipeline to manage a resource for you? Well, what this means is that Data Pipeline watches your data nodes for readiness, and when all of the preconditions for an activity are met, it will actually launch the resource for you, run all of the activities that need to happen on the resource, and then tear it down. So if you're doing something like daily analytics that take 3 or 4 hours, this is going to potentially save you a bunch of money compared to just having a compute resource sitting there idle half the time. So easier to pay for what you use. On the other hand, there are plenty of jobs that either take some manual configuration or that are running in on-premise resources, and we support those too. So this is where resources that you manage come in. So to manage these, we're distributing a Java-based task agent, and it's a really small little jar. You install this on a compute resource you control, and it sits there polling our APIs for work. It says, hey, I'm this agent. This is my account ID. You can assign these things to logical groups. So you could have a group of task agents running, say, on your on-premise servers, and a separate group of task agents running on AWS web servers. And when you create activities, you say, this activity should be executed by that group of agents. So then when the activity is ready to go, next time an agent polls, the web service says, oh, work's available. Take it and start doing it. And then the web service monitors the agent for liveness. If the agent goes down, it's no big deal. next time a different one polls, we'll reassign the work to it. And you can use this to run your activities anywhere within reason. I haven't tried a smartphone, but reasonable servers at least. And so if you have manual configuration, you can bring up your compute resource. You can do whatever manual mucking around you need to do. On the other hand, maybe you don't have any manual install, but you want to use existing on-premise compute resources. That's fine. You just install this agent on-premise, as long as it's a vaguely Linux, Unixy machine, and as long as you have internet access to our API endpoint, should just work. For our copy logic, that's included on the agent. So if you want to start running a copy between, say, on-premise logs and S3, or if you want to copy between on-premise JDBC and AWS JDBC, the agent has that logic, so it can access your on-premise database, and then it can reach out to your AWS compute resources and seamlessly connect the two. And again, these activities are scheduled and managed just like anything else in the system. So a little bit of configuration. Is this work? Where is the computer for this? OK, got it. All right, much chaos later. So here is the data pipeline console. So these are all of the pipelines I've got configured and running. And we can go create a new one. And say, Catherine's pipeline. This is just a description, so if you want to look at it later, you can say, this helped me keep track of what on earth I was trying to do. And then pipelines are associated with roles. So the idea of a role is that data pipeline is going to be taking a pretty broad range of actions on your behalf. It's potentially going to be looking at your S3 data, your Dynamo data. It'll be launching EC2 instances on your behalf. And maybe you don't want it to have full access to do whatever it feels like with your account, right? So if you're familiar with HOSM roles on EC2, we're actually using these throughout the system. So when you configure a pipeline, you pick a role, you associate the pipeline with that role, and then whenever we're doing something, we actually use the role to do it. So if you want to, for example, allow the system to look at your S3 data and your Dynamo data for availability, but you want it to keep its hands off of your RDS data, you can use these to enforce that. And then you can also choose what role you decide to push to any EC2 instances it launches. So if it's provisioning compute for you, you can very carefully sandbox this compute so that if anything does go haywire in your scripts, the blast radius is significantly limited. So I'm just going to use the default roles. I'm going to create the pipeline. And then let's just say we want to back up Dynamo. We'll just drop in the Dynamo to S3 replication template. You can see here we've got two data nodes, Dynamo and S3. For Dynamo, you need to provide a table name. So my example, I don't think this is actually going to work because I don't have any Dynamo table named that, but. And then for S3, similarly, you provide a path. And Matt touched on this a little bit, but we provide this expression language that allows you to embed things like the date and the time into your paths. So for replication, it's not going to be very useful if you clobber your old backup every time you have a new one, right? You want to actually keep track of historical states that if you realize you had a bug a week ago, you can roll back to it. So here, I'd say, start time dot format. Maybe this is a daily job, so I'll just put the day in, month, day, and then it's going to be, I think, CSV data. So this way, I'll get new data each day. I won't be clobbering the old data. And you could potentially do something interesting here. You could configure S3 to start aging your backups out to Glacier so that you save even more money compared to just having this bulk Dynamo data sitting there in S3. So once it's all done, save that guy. Yeah, there's a validation error. My bucket is imaginary. That's OK. And then once I have a pipeline running, you can see we show you some brief details here. So I can see how much my pipeline's been doing lately, how many times has it completed, how many times has it failed. This one's failed. So let's go look at it a little bit. So I'm going to say, look at details. I actually created this thing to have an example of a good script and a buggy script. My buggy script is failing because it's echoing false. But you can see here, we show you what went wrong, what our error code was, why the error happened. In this case, it's because I'm running a manual script and the thing is failing. And from here, you can start downloading logs and actually diving into the problem. Once I think I've fixed the problem, I can go up here, say, oh, problem solved, my script bug is gone. I'd click rerun to make the system retry, and it would just pick up where it had stopped for that particular workflow. So back to the slides. So it's provisioning in a nutshell. Yeah, can you turn this one back on, or? This is what I get for using a Mac, right? There you go. Brilliant. All right. So you can also provision these things through the CLI or the API. I decided to skip on the code samples. But if you're doing it through the CLI, we have a JSON pipeline definition format. So here's an example of me defining a copy between RDS and S3. So I've said that the name of my activity is copy. Type is copy action. I'm going to have one input data source, which is the RDS data. I'm going to have one output, which is the S3 data. It's using runs on, which means that for this pipeline, Data Pipeline is going to configure an EC2 instance for me. And there's my configuration right below. And then the schedule is off the screen, but you can imagine what it would look like. So for this one, imagine it's a daily schedule. Whenever the copy is ready to go, we'll spin up an M1 small, run the copy, tear down the M1 small. I have no idea why that is showing up there. Oh, here's the monitoring example. And here's our pricing. So again, this is pay for what you use, no advanced charges. The way this works is that the cost is a function of how many activities or preconditions you have in every running pipeline. And we have two types. We have high frequency and we have low frequency. A high frequency activity is one that you've scheduled to run more often than daily. So every 12 hours, every hour, 15 minutes is the fastest option. And then a low frequency is one that's daily or less. Daily, weekly, monthly. You could schedule it to run, I don't know, every 17 days or every 8 months. Not sure exactly what your use case would be there, but whatever makes you happy. And then for activities running on AWS, you have one set of prices. And if you go purely on-premise, then it's $250 versus $150. Our free tier is 3 low-frequency AWS preconditions a month and 5 low-frequency AWS activities. So with the free tier, if you wanted to do something like replicate Dynamo data once a day to S3, that's a single activity, so completely covered by the free tier. If you wanted to replicate your Dynamo data and start moving stuff between 2 different AWS databases, both of those tasks will fit within the free tier. The prices here are monthly, but it's actually prorated hourly. The monthly is just to make it a little bit easier to wrap your head around what your expected cost is. So if I created a pipeline, I scheduled it to run once a day, I ran it for 6 hours, and I turned it off. Let's say 6 activities in the pipeline. It would cost me 60 cents times 6, $360 a month. And then that would be prorated for those 6 hours. So divide by, say, 30 times 4. I don't know. It'll cost me a couple cents to have that thing active for 6 months. Or sorry, for 6 hours. For 6 months, it'll cost me a couple bucks. So it's 3 configured. And then you could configure them to run daily, 2 days, 3 days. Because it's low frequency, daily is the maximum frequency under the free tier. And if you wanted to have one set and then midway through the month, you could delete those pipelines, swap them out for a second set of pipelines. That'll be fine under the free tier. Yeah, just like EC2, this does round by the hour, so you know how that math works. So goals, talked about the problem, how Data Pipeline will help you solve it, and then saw provisioning examples. Our current status, right now we are in private beta. Public beta is coming soon. If you have questions or if you want to try this thing out, we are at the big data booth for the rest of the day. You can come find us, and we are more than happy to talk to you about this stuff. And I have, looks like 1 minute left. So